Hello, my phenomenal viewers, and welcome on today's episode. On today's episode, we are going to be answering this GCE 2020 question 2, Roman 2. The question reads, solve the differential equation dy on dx is equal to xy minus x, and given that y is equal to 2 when x is equal to 0, express y in terms of x. So this is the differential equation that has been given to us for us to solve, and at the end let us express y as a function of x. So let us dive into solving this question together. Solution. So we have dy on dx to be equal to xy minus x. So when you look at this differential equation, you will notice that this is a first order differential equation, since the highest derivative there is dy on dx. So it is a first order differential equation. Now, you have to also look at the differential equation whether it is that of separable variables. What do I mean by separable variables? Is it possible for us to bring all of the terms containing y on the side of dy and all of the terms containing x on the side of dx? If it is possible, then we say that the differential equation is of separable variables. So looking at the left hand side of this equation, you see that we can factor out x since x is common. So this implies we are going to have dy on dx to be equal to x into y. When I factor out x from here, I'm going to be left with y. So when you factor out x from here, you simply take the initial term there is divided by x. You see that xy divided by x cancels with x. You will be left with y. So I do the same thing. When I factor out x from here, I simply take x divided by x. That gives me what? 1. So when I factor out x, this is what I'm going to have. The next thing that I will do is for me to multiply both sides by dx. So this gives me dy is equal to x into y minus 1 dx. Now, if I decide to divide both sides by y minus 1, this is going to give me dy on y minus 1 to be equal to x dx. When I divide both sides by y minus 1. Now, you see that I've succeeded to separate the terms or the variables. On this side that I'm having dx, I have only x, and on this side that I'm having dy, I have only y. So it shows that this differential equation is of separable variables. Now at this level, I can now integrate both sides. So I take the integral of this side and I take the integral of this side as well. Now, whenever you have a rational function, for you to integrate, the first thing that you need to do or observe is that you should look at the numerator. If the function that is found at the numerator is derivative or can be expressed as the derivative of the function that is found in the denominator, then you express it. If it is not the derivative directly, you express it as the derivative of the function that is found in the denominator, and when you've done that, you simply code the integral as the ln of the denominator. So now when you look at this function, you notice that this is the same as 1 divided by y minus 1 dy. So it shows that the function that is found in the numerator is 1, and when you differentiate y minus 1 with respect to y, you're going to have 1. So since we have 1 in the numerator and 1 is the derivative of y minus 1, it shows that the integral of this function will simply be the ln of the denominator. So based on the explanation that I've given, it shows that this integral is ln y minus 1. I'll put the absolute signs. to take care of any negative value that we are going to have, since the mean of a negative value doesn't exist, is equal to, now the integral of x dx. We use the general rule of integration. So if you have the integral of x raised to the power n dx, this would be x raised to the power n plus 1 divided by n plus 1 plus our constant of integration c. So you just add 1 to the initial power of x, then it's divided by the new power. So this is what integration is all about. So the initial power of x here is 1. When I add 1 to 1, I'm going to have 2. Then I divide it by 2. So I have x squared divided by 2. Now, since we've been given some conditions, which is when y is equals to 2, x is equals to 0. So let me add my constant of integration here, plus c. Since it is an indefinite integral, I need to introduce that constant of integration. So it shows that c in this case is equal to mean of y minus 1 minus x squared divided by 2. Now, when y is equals to 2, I'm going to have mean of 2 minus 1 minus, when x is equal to 0, I have 0. So mean 1 is 0. So it shows that the constant of integration in this case, c, is equal to 0, since mean 1 is equals to 0. Now, it shows that the function would be mean y minus 1 absolute value is equal to x squared divided by 2. Now, since the question has asked me to express y in terms of x, it shows that I need to make y the subject of this equation. Now, remember that mean is simply log base e. Log base e. So this simply means that I'm going to have log base e of y minus 1 is equal to x squared divided by 2. We now need to leave from logarithm to index. So when you are leaving from logarithm to index, you maintain the base. So the base is e. Then this answer here becomes the power. This answer becomes the power x squared divided by 2. Then this power in here, or this value in here, becomes the answer, y minus 1. So this shows that y is equal to e raised to the power x squared divided by 2 plus 1. When negative 1 crosses and comes this way, becomes positive 1. So it shows that the function y in terms of x is equal to e raised to the power x squared divided by 2 plus 1. So this is how you solve this differential equation. Okay, if you loved this video, please help me and share so that it can get to many students as possible. And if this is your first time coming across any of my videos, please do not hesitate to either subscribe or follow me, so that whenever I upload videos like this one, you will be notified. And thank you for watching. Stay blessed.